when we combine functions, again, we need to make sure we understand how to analyze domain. The range is a little bit more complicated, so we're going to do that mainly by graphs. But we want to also identify key parts of functions, vertices, starting points, and we can often use a table of values to get some patterning. So looking at this one here, the square root function, the domain of a square root function is going to be x is going to be greater than or equal to 0. And the range will be the same, so y is going to be greater than or equal to 0. So that is a starting position, so we should make sure that we observe that as to help us analyze the combined function. Here we have x plus 1. This is a linear function, so x is all real numbers and y is all real numbers. Okay, so when we put this together then, we end up with f of x times g of x, so that's going to be square root x. So we're going to have our square root of x times x plus 1. And we want to know what the domain of this is going to look like. Okay, well, we know that the domain of this must be the domain of the most restrictive part. So here the domain of the combined function, when we multiply, in this case we're multiplying this together, the domain is going to be x is going to be greater than or equal to 0. Okay, now the range, again, we're not necessarily going to need to do the range, but to do the range we can do some analysis. We can graph it. Okay, so when I graph it, the graph is going to look like this. So for now, we're going to really just stick with the graph. So we end up with a graph that has a starting value at 0. Okay, and it's going to go up kind of like that. It's not quite a parabola. It's kind of a little bit sharper than a parabola, so it's going to be more like that. Okay, so when I take a look at my range of this function, I know that the lowest point is going to be 0, and it's just going to keep on going up. And again, this is from, just going to make a note here, this is from the graph of the function. So this is a little bit hard to analyze without a graph, but we can also, what we could do is we can put together a table of values to help us figure out what this graph is going to look like. Okay, so I kind of cheated, I already graphed this, but what is this graph is going to look like? Okay, so I'm just going to make a table of values here. And I have my x, and I'm going to choose, okay, I'm going to start at 0. And I'm going to choose kind of some nice coordinates and see if I can get some patterning. So the f function, f at 0 is going to be 0, 1, square root 2, maybe I'm going to put in a nice value here of 4, x is 4, and the f value is going to be 2. Okay, and then I'm also going to put some values in for the g function. So there's my g function. At x equals 0, y equals 1, x equals 2, 1, y equals 2, x equals 2, y is 3, x equals 4, y is 5. Okay, and then for a combined function, this is what I want. I want the combined function. Okay, so f times g. And when I combine those, I can get some coordinates. That's going to be a 0. That's going to be 2. This is going to be 3 root 2. This is going to be 10. And looking at the pattern of this, we can kind of see that this is actually an increasing function. So x is 0, y is 0, x is 1, y is 2, x is 2, y is approximately, that's going to be 4.2 about, so somewhere around here. Okay, and x is 4, y is 10, so 4, 5, 6, 7, 8, 9, 10, somewhere around here. Okay, and we can kind of see that it's going to start here, it's going to go up, and there's no reason to believe it's going to go down. So when we look at the expression, as x gets bigger, the y is just going to get bigger and bigger, so that will then justify the range that we got here. So we could do this based on a table of values. It's a little bit harder since we're going to have to kind of see what's going on with this, and we have to then predict what's going to happen as x gets large. So in this case, we can make the conclusion that x is just going to get larger and larger, so the right hand bound is going to be infinite.